1.2 Intercept, Symmetry, and Graphing Key Equations. How do you find an intercept if you're only given the equation and not a graph? Well, you won't want to go through all the trouble of graphing it by hand and then trying to figure out where the intercepts are, because you might be wrong. So, as we said in the previous video, the X-intercept is when y equals 0, and the Y-intercept is when x equals 0. Therefore, if you were to say find the Y-intercept, you would set x equal to 0. In this case, it would look like y equals 3 times 0 squared minus 6. Now, if you just simplify this, 3 times 0 squared is 0, of course. Y equals negative 6. And since we've already plugged 0 in, and since all y-intercepts have to have an x of 0, it would become 0, negative 6. Now, if we were to find the x-intercept, that means that y would have to equal 0. So, 0 equals 3x squared minus 6. Now, this is a little trickier. So, first step, add 6 to each side. 6 equals 3x squared. Divide both by 3. 2 equals x squared. So then, square root both sides. X equals the plus or minus square root of 2. Now it's plus or minus because x was squared, so we don't know if x was negative or positive. Therefore, we put plus or minus to cover all our bases. Using intercepts, we can plot a much more accurate graph instead of what we would be doing with just plotting a graph by hand. Okay, now for symmetry. Now there are 3 types of symmetry. Symmetry with respect to the x-axis, the y-axis, and the origin. So let's start with the x-axis. X-axis symmetry is, so say you have something like this. If something has x-axis symmetry, for every point, say x, y, there's another point that is x, negative y. In this respect, it has x-axis symmetry. Think about it like this. It's almost like you've taken this part, flipped it over a mirror, so this is the same distance as this point. This point is the same distance to here as this point is to here. For something to have y-axis symmetry, here's the same graph that we had before. For every point x, y, there's a point. So say we pick these 2 points. This would be x, y. So for every point x, y, there is a point negative x, y. Just like before with x-axis symmetry, this point is the same distance to the y-axis as this point is to the y-axis. Same goes with these 2 points. They are, excuse my bad drawing, but they're supposed to be the same distance to the y-axis. This would be your mirror, and you are flipping everything from here over to here. So then, symmetry with respect to the origin would be same graph as before. For every point x, y, there is a point negative x, negative y. So in the case of symmetry with respect to the origin, you're taking this and you're just twisting it this way. So, I'm kind of drawing what it would look like as you're bringing it this way. You're turning it. Turning. So, in summary, if you have x-axis symmetry for every point xy, there is a point x, negative y. For y-axis symmetry, for every point xy, there is a point negative x, y. And for symmetry with respect to the origin, for every point xy, there is a point negative x, negative y. So say you were to take this equation, x squared minus 4 over x squared plus 1. In order to find your zeros, or your intercepts, so say you're looking for your y-intercept, you would plug in 0 for y. Now, in order to get rid of this division, you would multiply both sides by x squared plus 1. However, when you multiply both sides by x squared plus 1, since this is a 0, it'll simply turn into 0 equals x squared minus 4, from which you'll get 4 equals x squared, square root both sides, and you get x equals plus or minus 2. Now that plus or minus 2 is important because it'll tell us later on whether or not it has symmetry. Now, to check for symmetry, if you were to check for x-axis symmetry, you would replace y with negative y. And nope, these two equations are not the same. To check for y-axis symmetry, you would replace x with negative x. So it would be negative x squared minus 4 over negative x squared plus 1, which is the same thing as the original. So we know that this graph has x-axis symmetry. So now to check for symmetry with respect to the origin, you would replace both y and x by negative y and negative x. Now this wouldn't work since it would turn into negative y equals x squared plus 4 over x squared minus 1. So we know that we do not have symmetry with respect to the origin. Now we want to use what we've learned so far to be able to graph key equations such as y equals x cubed. So first things first, let's look for intercepts. So X-intercept would be 0. Y-intercept would also be 0. We want to look for symmetry. So the equation was y equals x cubed. Now in order to look for x-axis symmetry, we replace y with negative y. Negative y equals x cubed. Now these two are obviously not the same, so no x-axis symmetry. No. Now for y-axis symmetry, we replace x with negative x. And no luck. This will turn into negative x cubed. So we want to look for symmetry with respect to the origin. Again, y equals x cubed. We replace both y and x with negative y and negative x. So this will turn into negative y equals negative x cubed. Now if we divide both sides by negative 1, or multiply, y equals x cubed. Yay! This means we have symmetry with respect to the origin. Now we want to take what we know so far. X-intercept and Y-intercept are both 0, 0. And we know that we have symmetry with respect to the origin. So if we were to plug in a random point, say 1, y equals x cubed. If we were to plug in 1 for x, so this one right here, we would get y equals 1, which means that there's a point 1, 1. And since we know that we have symmetry with respect to the origin, if there's a 1, 1, there must be a negative 1, negative 1. So let's just make a table again. We've plugged in 1 so far. We had 1 cubed, which was 1. And then let's plug in 2. 2 cubed, which is 8. So I don't actually have enough space on here, but it would be somewhere way up there. So keeping that in mind, so remember that we had a point here at 0, 0, a point here at 1, 1, and a point here at negative 1, negative 1. And we had determined that we would have had a point at 2, 8, which means that we would also have had a point at negative 2, negative 8. Less points to plug in. So now the graph looks something like this. Now that same process can be followed if you want to graph something like x equals y squared, or y equals 1 over x. Try it on your own and then graph it in your calculator and check what you got by hand with what you got on the calculator.